we're going to start. I don't know how many people are still going to trickle in after lunch. Yeah, that's so much more interesting than Domino. Okay, so I'm Aldora Louw. I'm with PricewaterhouseCoopers. And I guess everybody can read. We're going to be speaking about Domino today. So Lotus Domino is inherently secure. Not much reaction from that one. Some of you guys are looking at me like, is she crazy or on some kind of a trip or something? Well, that's wrong. Big misconception. But I bump into so many people on a monthly basis, Domino administrators usually, that look at me, and when I speak to them about Domino security, their line back to me is, we don't need to worry about that, Domino is inherently secure. And it's not only Domino administrators that have told me this. I've heard this from IT managers, even security administrators. So I'd like to dispel that myth today. I'm going to focus on about 5 or 6 security configurations that need to be set in Domino to make it secure or more secure. I'm going to touch on each configuration, briefly discuss why people don't really want to implement it. Then I'm going to have a demonstration to show what will happen to your system or what potentially can happen to your system if you don't have that setting in place. And then just go over how to get that setting in there. So, security is not automatic. Very brief, everybody knows about these 6 things. Just like any other any other IT platform, you need to have all of these in Domino as well. Again, everybody knows these: physical security, logical. They all support the last mentioned one there, application level security, which is Domino, what we're speaking about today. The very first one, security configuration I'd like to touch on is the server ID password. I think in all the clients I've gone to, I've maybe seen 2 that actually password protect the server ID. And the main kickback I get when I say, look, you really need to password protect your server ID is, well, if we password protect that, then our server's going to go down in the middle of the night, nobody's going to be there to restart the server, and our availability figures are just going to go into the ground. So what happens if you don't have your server ID password protected? I guess people are going to look at me now and say, well, your demonstration hinges upon the fact that you've gained access to Windows, so you've compromised the OS, you've compromised the network. But that happens, or you have somebody on your internal network. So with this demonstration, some hackers got in and they've got file level access to your Windows server. And they've got hold of your server ID, and let's see what they can do. Show you what I've got running here. On this machine, I have the Domino server running. Then on this one down here, I have a client. And what I'm going to do now is I'm just going to, because we already have the access to this machine, I'm not going to show compromising the machine. I'm just going to do a netstat over to it. Not a netstat, a netuse. And then I'm going to just start up rprompt so that we have command line access to it. Just to expedite things, I've already got all the files copied over there and everything. Okay, so we've got R prompt running here. Before I actually go in and show you what I'm going to do, let's just look at the state of the address book right now. We're going to find a user, change that user's password so we've got access to that user's account, and then put that user into one of the administrator groups, that way giving ourselves admin access to the Domino system. So the user whose password I'm going to change is this user to admin user. If you look at the hash there, that's actually the hash for the word password. It ends in FC4. If we go back and look at the groups, I've created this admins group, and that's where I'm going to add the user in. The admins group is part of local domain admins. Okay. Okay, if I can type, it will help. Let's try that. Okay, so we just changed the password, and I'll actually go back into the document to show you that that password has changed. And let's add them to the group now. Set the admins group. Okay, so we've changed the password and added the user to the group. Let's go back, check in the group. So there's our user that we've now elevated to admin access. And seeing as we've changed the password, you see it doesn't end in CF4 anymore, so we can now log on as that user and do basically whatever to the Domino system via the web that we choose to do. So how do you stop some hacker from getting to your Domino server and doing this? Firstly, password protect your server ID. Now, lots of people are going to say, well, then my server is going to be crippled if it happens to restart or something. What then? Implement fault-tolerant technologies. You can, on Domino, you can cluster. You don't need to even use Domino clustering. Use some form of clustering. That way, if one of your servers goes down and dies, it's got a friend somewhere that's going to come up and carry on doing its job for it. Obviously, you need to harden your OS and stuff and try and prevent somebody from even getting to your server. Next thing I'd like to move into is the two different Domino interfaces. Domino started when it was still called Notes, and there wasn't the whole confusion about Domino and Notes. It was just the Notes client interface. And then in version 4, Lotus brought the web interface. I'd like to focus on the Notes client interface first. The two main advantages you get from the Notes client interface is, one, you have two-factor authentication because you have your Notes ID and you need the password for the Notes ID. And then you've got your public key type infrastructure. The public key type infrastructure, there's two parts to that. There's the global trust, which is the root certifier, and that's how most people use Notes. There's not very many I haven't really seen it implemented where people actually use the second one that I have up there, which is the more specific identification of users. So what kind of trust should you be using? Should you just be using global trusts, which is, again, just a default Domino installation? Or should you go in and make a few additional settings so that you can specifically identify users? What I'm going to show in this demonstration is if you just solely rely on global trusts, there are some benefits. I know some people want to do that because that way if somebody loses their ID or forgets the password or something like that, they can just go and recreate that user. That can be a bad thing because if somebody leaves their certifier lying around, some hacker can find that certifier and go and recreate the admin user. And that might seem a bit far-fetched, but in the pen tests I've done, I've found node certifiers in the strangest places. I found them on anonymous FTP servers on the internet, on the Domino server that's also visible to the internet. So compromising the certifier ID, or I guess you can't call it compromising if you just find it. Finding the certifier ID and using that to compromise the Domino system isn't that much of a far-fetched idea. So the next demonstration, I'm basically going to show how you just recreate a Domino administrator's ID. Come back over to the workstation. The ID I'm going to create is this Aldora Louw person's, seen as that's the admin ID. Just to prove the point, I'm actually going to switch locations to this fake location. And you'll notice the fake location that I've got running is also Aldora Louw, but the certifier is one word black hat, whereas the real server is 2 words black hat. And just because of the way I've got my machine set up, I'm also going to need to start a fake server. And everybody knows you create nodes IDs from the admin client, so I'll get that started as well. Okay, just plain and simple, going to register a user. You'll notice that the certifier I'm using is the black hat with 2 words. That's the certifier we found somewhere. We already know who we want to recreate. I'm going to make the password on this one fake. Of course, I didn't set it to actually create an ID file, so let's just do that again. Okay, there's nothing much to that, but what I'd like to demonstrate and why I did that is to show that if we switch to that ID, the fake Aldora that we've just created, there's the real admin's mail, and we can actually get into that. The reason we could do that is because we're only using global trust. So the server's not actually looking at who I am when I connect to the server. Quick way to just look at that is if we go into the ID and look at the ID's properties. If we look here at the issuer key identifier, it starts as 1PA. You'll see when I look at the other ID, which is the real admin's ID, that will be the same because that's that root certifier that we used. But the key identifier, which is the identifier of the notes ID that we recreated, will be different. So this one starts with 1EA, 1E5, I mean, okay. So let's switch IDs back to the real administrator. Go through same thing to get to the ID. So that first one's the same, just see the bottom one's different. So basically what happened, if we switch back here, and speak about how to combat somebody actually going in and just recreating your users. First thing is get your server to actually check the public key. When you do that, the Domino address book actually has the whole public key stored in the address book. The server looks at the ID trying to authenticate and it says, let me see your public key. It takes that and compares it to the one in the address book. If that had been enabled on this server, it would have said something to the effect that your public key doesn't match that one contained within the address book. So that's one way of stopping people from just cloning your users. Another thing that often happens is users get paranoid and they go, oh, somebody stole my notes ID, or somebody stole my password, or I told somebody my password and I don't want them reading my mail anymore. And then you need to create a new ID, and you don't really need to do that. If you've got your server, there's something else you can check, and that's the password on the ID. So not only is the server, you can set the server not only to check the public key, but you can also check the password on the ID. So if I've got my password on my ID and I've told 3 of my friends and they're using my ID with the password on, and I decided I want them using my ID anymore, I changed my password from password to something else. And when they try and log on, it's going to tell them the password on your ID does not match that contained in the server. That also combats somebody from walking up to a machine and stealing an ID. Because if as soon as you change the password, that ID that's been stolen is no longer valid. Something that I touched on before we did the demonstration is you need to protect your certifiers. In Domino 6, there's actually now a feature where you can have notes administrators create new user IDs without having physical access to the certifier. That's something everybody should investigate and see if you can implement it. Then if you're still using 5, logically protect your certifier IDs so that if somebody inadvertently goes and puts it on an anonymous FTP server out on the internet, when a hacker finds that, they're going to spend days trying to crack the password on that certifier. And then something like your root certifier, you shouldn't just leave that lying around so that admins can keep it on their workstations. Keep that like you'd store any other public key infrastructure root certifier, where if you store it in a safe, wherever you think safe, store it there and have multiple passwords on it. And I guess the last thing about protecting users' IDs, I've seen lots of people, when they create IDs, they store them either on a network volume somewhere or in a Domino database. And again, that's just giving some hacker keys to the kingdom. If they compromise the server where the IDs are stored, and suddenly there they've got a whole volume that's got everybody in the whole company's IDs on it. In Domino 5, Lotus introduced the ID storage database, and they've continued to use that in 6. If you implement this, people's IDs are stored encrypted in this database, and you actually need administrators to help unencrypt the IDs. So it's something else that you should also look at. We can move on to the web interface now. As soon as you move to the web interface, you lose those 2 key components of the client interface. Suddenly you don't, and this I'm talking about just the default web interface, default install. Suddenly you don't have 2-factor authentication anymore, and it's only a username and password, and obviously the public key infrastructure is gone as well. On a default Domino install, a user can have something like ridiculous, like 15 usernames, and that's what I'd like to speak about now. People often use that because they say it's just easier and it helps the users not have to remember a specific username, but I think sometimes it actually confuses the users. And it makes hackers' lives a lot easier. What we've got here is, we've got a user called Joan Smith and John Smith, and their passwords just differ by 1 keystroke. So in the way I've got the server set up to use the more password variations, less security. So I just log on as Smith. Depending what password I type in, that's the user I authenticated as. And it's only when you go to something specific, like a mail file or something, that user will actually know, if it was a hacker, that hacker will actually know who they just authenticated as. So I just authenticated as Joan Smith because I typed default 01 as the password. If I typed default 02, I'd be authenticating as John Smith. So there, obviously, you can see how this setting makes hackers' lives easier. Instead of having to know that the username is joan.smith, you just type in Smith, and you just send a brute force password generator against it. And instead of just guessing passwords against one user's name, depending on how many Smiths there are in the company, that's how many people you're going to be guessing passwords against. So how to make this more difficult for hackers? First thing, set your authentication to less name variations, higher security, more security. And in Domino 6, you can encourage users to have better passwords by setting password complexity and also password expirations. Any system administrator or security person will know that users are the weak link, that we can control technology, but users need to be managed. Moving on to that thought about controlling technology, there are 2 different hashes that you can use for Domino passwords. The one I have at the top there, let's use my laser pointer. That one there, 32 character hash, is just a normal hash, and the one below it is a salted hash. This is again just one simple setting that you make. There are tons of password crackers out available on the internet that can crack that first hash. It's a one-way hash. If my password is password and somebody out there's password is password, the hash is going to be exactly the same. With the salted hash, there's actually a salt that's unique to the user that makes each salt different. So knowing that you can control technology, it's a good thing to implement the salted hashes. But obviously, again, people go to the other extreme and say, well, we have salted hashes, we don't need to worry about making users have decent passwords. Nobody can crack the hash in any case. But if somebody has a stupid password, the hacker's not going to go to the extent of trying to get the hash, crack the hash, if they can just go Sally and password and get into the system. The next demonstration, I'd like to show how people can gain access to Domino hashes and what you can do with them. In Domino 5, you couldn't gain access to the hash via the internet. But I think some of you noticed in Domino 6, if I just go to any user, the hash is just displayed right there. So from the internet, you're browsing and I'm authenticated as an unprivileged user right here, and I can see the hash. The way you have to do it in Domino 5 is you have to actually get to the client and go through what I call the viewer and just find the HTTP password. And there it is too. So this data was, in Domino 5, it was hidden. It was never, anybody could get to it if they could get through the client. So what I'd just like to show here, demonstrate what a hacker would obviously do with something like this, is just grab that off right there and then run it through a password cracker. I'm not going to run it through a password cracker now because that's going to take too long. But what I have is just simulate a password cracker. I have a hash list. And basically that would be the outcome. We found out that the administrator of the system's password is password, and the hacker would then have admin access to the Domino environment.
Can I ask a question?
Yeah.
Is it a MD5 hash?
It's not an MD5 hash. It's pardon?
Which one is it?
It looks like an MD5 because it's 32 characters. I'm not sure what hash it is, but it's easy to reproduce. It's a Lotus proprietary hash, and it's actually contained within the @password function.
Okay. Is there, I apologize because I'm not that familiar with those notes. If I had a dictionary, is there a utility I could run to generate all the hashes of the dictionary values?
Yeah, you can write your own. If you just run your dictionary through the @password function within Domino, you can create a full word list like I have here. If you don't feel like doing that, there's several password crackers out on the web that will do it for you.
Thank you.
There's one that works quite well, is Domino Hashbreaker, and it's actually free.
Good to know.
So how do we stop that? Yes? I haven't found one yet. I'm trying to see how that would be done. It's one of my research topics. You're a lot safer, but obviously you're never safe. So hiding data. What I just showed you was where Lotus took the hash in version 5 and hid it. And obviously that's not really secure because anybody who has access could just open the little viewer thing and see the hash. And I've seen this used in many applications. I've seen HR applications where somebody has used that hide functionality to just hide the information off of the UI, but the data is still there in a field, and going through the viewer, you bypass all the settings of the user interface and actually just see whatever data is there. So just got another database to demonstrate that more clearly. The database I have here is called the shadow database. And I'm actually just going to switch to location here. Okay. I have a document in there, and the user I'm using has manager access to this database and also has an encryption key embedded in the notes ID. The bold black text where it says this field is encrypted, that's the field that I'm protecting with the encryption key. And then I'm using the hide functionality to hide this function is only hidden value. So only somebody who has a high enough level of access to edit the document can see that. What I'm going to do now is switch users to a user that does not have the encryption key and also only has reader access to that database. So first off, when the user goes in, the first message the user gets is some of this data is encrypted and you're not going to be able to see it. Like, okay, so we know that's encrypted, so I can't see it, but if I click on the edit button, that user can't see that information. But again, if we go up to the viewer, there that hidden information is again. So this is exactly what Lotus was using in their address book, which we saw in the previous demonstration. And you'll notice that the encrypted field doesn't even show there. It shows which key was used to encrypt the data with, but the encryption key is just missing. Well, the field's gone. I'd like to demonstrate that from a web interface as well. I'm logging on as the user with no privileges, or read privileges only. And the user can't see either of those fields. Again, if the user tries to edit the document, nothing happens. So from a web browser perspective, you can actually use hiding as a kind of security, but you should really not rely on just hiding data as a form of security. Even though from the web browser I don't know of any way to get to this information, but the trap people fall into is somehow that user also has access to this database via the notes interface, goes into the viewer and sees the data that they're not supposed to be seeing. So how do you really hide information? The first thing is if you have a database with critical information that you don't want everybody seeing, encrypt that field and encrypt the data within that field. And then the second thing for databases like the names NSF file that just displays, especially on version 6, that just displays hashes to everybody. In version 6, Domino now has a new feature called extended access. Implement that extended access. The outcome of extended access is very much the same as encryption. If you go look in the viewer and you don't have access to that field, you will not even see that field. Well, you'll see the field, but you don't see the data. The data is blank. Basically, what extended access is it's field level access control lists. There's just one caveat with extended access. It will only work on a database that inherits from the pub names NTF template, and that's basically the template that your name and address book inherits from. Execution control lists. This again is something that I hardly ever see implemented. With Domino 4, people really didn't, Lotus had the execution control list wide open. In Domino 5, they started to put some entries into the execution control list. But people really don't use it, and users I haven't seen anybody train their users to react when they see the pop-up box. So what I'm going to do in this next demonstration, I'm going to have somebody send a user an email. The user is going to click on the email, and I'll first show it with the user responding appropriately to the execution control list warning, and then show what happens if the user just ignores the warning. Created another database to demonstrate this. If a user wanted to be malicious, they wouldn't need to create another database. They could just add the form to their mail database. And again, this is just proof of concept. You can send this kind of malicious email in many different ways. I know lots of companies that do use Notes Mail tend to send out invitations that have a I accept or I reject button attached to it. This kind of code can be attached to one of those buttons as well. So the reader we're going to be sending this to is email reader. And we'll make the topic here Okay, so we're sending them an email that says it's an urgent email or urgent emergency virus update, and they need to click on the email and follow the on-screen directions. Just switch over here to the server. And you'll see an email just being delivered to email reader. Switch back over here and switch and become email reader. Go into email reader's email. There the email is that we just sent email reader. Double click on that and the execution control list alert comes up and says, somebody's trying to do something to your machine that they're not supposed to be doing. And the user has three options. If they select the first option and say, do not execute this action, nothing happens. If I just switch back over to the server, you'll see the server's just static. But if this user does what users are inclined to do when an error message pops up, just says execute this action, clicks OK, a pop-up box comes up and says the emergency virus update has successfully been applied to your machine. Hit the enter key to complete the installation. And the user does that, and the user's happy thinking that whatever virus isn't going to attack her machine anymore. We switch back here. Right at the bottom, you'll see that an email has been sent back to Aldora. So on this machine, I'm now going to go back to that user account. Log in as Aldora, and there's the email from Email Reader. Open the email, and there's an attachment. Just open that attachment, and it's a Notes ID file. And if we look, we'll see that's Email Reader's ID file. So Email Reader thought that a virus update was being made to the machine. In actual fact, we got Email Reader's ID file and mailed it back to ourselves. Like I said, this is proof of concept. We could have got any file we chose. We could have decided to get the SAM file. We could have run Windows tools to get the users, formatted the hard drive, done whatever we chose to. So how do you stop this? On Domino 6, it's become a bit easier. They actually have, if you use security profiles, you can push down execution control lists to the user's workstation. In Domino 5, you couldn't do that. So you'd go and the administrator would set a execution control list and the user would change it. Then the next thing to do is have a process signer ID or an agent signer ID. You can call it whatever you want, but basically its function would be that every database you have that executes any kind of code, go and sign that database with this ID. Add this ID to each workstation's execution control list. That way, when the code executes, it will check against the execution control list and say, well, this code's allowed to execute, and the user's not going to see that warning box. And when the user does see the warning box, it's not going to be something that happens every day, so it should attract the user's attention, and hopefully the user will read the warning and click on Do Not Execute. With version 6, you can actually make that the user cannot update the execution control list, but there's still a flaw in it because there were the 3 options: do not execute, execute once, or or start trusting the user. Now, to update the execution control list, they'd click on Start Trusting the User, and you can prevent that, but they can still say, I'm going to trust this person one time, or just this one time. So there's no way of preventing somebody from letting malicious code run on their machine. Those few things that I touched on now were specific configuration settings within Domino that need to be made to get the system a bit more secure. What I'd like to speak about now is just general Domino design. One of the things that need to be kept in mind when you're designing a Domino system is that the system must support the business. And obviously with your business data, you have certain pieces of data that are private data that you only want people inside your company seeing, semi-private and public data like web servers. And this kind of data should also be segregated within Domino. Another design feature that I'd like to speak about is when you're doing a Domino install, don't just go ahead and click yes, yes, accept, and do a default install. Because if you do that, it's really easy for the next time a directory transversal comes out, everybody's going to know you've installed your Domino data under Lotus Domino data, and they can immediately get to it. So if you put it somewhere else, it makes directory transversals a lot less effective. And also on a Windows platform, separate your data and your application files onto different volumes. Enticement information is always good when you're trying to get into a system, so turn that off. On Domino 6, if you look at the source of the web page, it actually doesn't say that it's a Domino server anymore, but if you telnet to port 80, it tells you it's a Domino server. So the two settings down at the bottom can go into the notes INI file, and it will suppress some of the enticement information. Then this last demonstration circles back to the idea that you need to keep your business data separated and keep your IT structure separated in the same way that your business data is separated. With this demonstration, obviously I only have two machines, so you just have to bear with me there and follow what I'm trying to get across. Again, we're going to have this laptop be the attacking laptop, and this laptop's going to have to be two laptops. One, it's going to be a server in the DMZ that we've compromised, and it's also going to be a server on the internal network that's in the same Domino domain as the DMZ server that we compromised. And what I'm going to show then is that if you've compromised the Domino server in the DMZ and have admin access to that, you can defeat the purpose of the firewall and have that internal Domino server shoot out a netcat session to you, and that would get you command line access to the server on the internal network. So I'm just logging onto the server. I've already just set up a program document, which is how we're going to get it to give us to run a command. Set that up just to make things go a bit quicker. I'm going to edit this program document. Okay, on the program document, there where it says which server to run on, if we were truly attacking a server on the internal network, we wouldn't put the DMZ server's name in there, you'd put the internal server's name in there. Just run the time, change the time that this needs to run. Before I do that, let me just get a netcat session listening, otherwise none of this is going to work. Okay, so we've got netcat listening there. We've got the program document scheduled to run. If we look over on the server, the program document has just run. And if we come back to this machine, don't get it in time. Okay, come back to this machine. We've got command shell access to the first machine, or to the server. Let's quickly do. So having those two machines in the same domain, let some attacker who gained access to the machine on the DMZ now get access to your command line access to your internal network, and that command line that was shot out to the attacker's machine is running as local system, so they've got complete access to that internal machine. So how do you prevent this? Firstly, keep your DMZ servers separate from your internal servers and your semi-private servers. Another thing you can do is have different organizational units. So have a root certifier for your internal servers and have another root certifier for the external servers. Another thing that would have stopped this attack would be to configure your firewall to not just allow any arbitrary outgoing traffic. And then another thing you can look into doing is don't have just a default Domino install where you use username and password authentication for web traffic. Investigate using SSL certificates or some kind of two-factor authentication for servers where you have more critical data. So a higher level of security is possible, but not automatic. Any questions? Yeah.
These, like in a cookbook or where I'm headed?
The tools I used?
Yeah.
Or I do, but I'm not allowed to distribute any of them. I'd like to, but I'd get fired if I do. So. Pardon? Any other questions? Okay. Well, thanks for coming.